Okay, so this is problem 16 of chapter 16 of Giancoli 6th edition. So what we have is a square. The side is given to us just in symbols. The side is L, so let's draw the square here. On each side, on each corner of the square, we have a different charge. They don't give us the sign of this charge. We don't know if it's positive, it's negative. They just say it's Q. So whatever this Q is, if it's positive or negative, will be the same positive or negative for all of the corners. Okay. So we have Q for Q. Here we have 3 Qs. And here we have 2 Qs. This is one example. Different people will have different distributions here. And then they ask the force on different corners. So part A, they want to know what is the total force on the charge 2Q, on here, okay, on the charge 2Q, due to the other 3 charges. And they want to know force, so they want to know the magnitude, and they want to know direction. So what are all the forces acting on this charge 2Q? Well, I have a force coming from charge Q, so I'm going to call it here, this is the one in red, it's repulsive because, as we said, all the Q's have the same sign. So in red here, I will have this force from Q, I'll call it FQ. In blue here, I have the force from 3Q, also repulsive, so pointing up. So I'll call it the force 3Q. And I also have force coming from 4Q, and I'll make it the drawing in green here. This is the force from 4Q. Okay, and that's it. Now we just have to add all of these forces. Using, again, we need to look at these forces in the x direction, the y direction, so we have to decompose these forces and then use Pythagoras and so on. Okay, so let's go. Let's start with our green force, the FQ. FQ is entirely in the x direction, right? So we know that FQx is everything that we have. Is going to be K. Look at your book for the value of K. The charge Q, the charge 2Q, where it's acting, and the distance. Well, I don't have a number for this distance. I'll just call it L squared. And in the y direction, well, in the y direction, we know there is nothing. This force is entirely in the x direction. Let me get the blue one, the F3Q. What is the F3Q? Well, it's entirely in the y direction. So in x, it is just 0. And in the y, we'll have the whole force, which is K. Now we're playing with 3 Qs. Then multiplying by the 2Q where we are at, divided by L squared. All right. What else do we have? We also have the green force. And let's go write down what we have there. We have, now this one we have to be careful because there is an angle. And so there is this angle here. But what is this angle here? Well, let me go make this whole line here. And well, we are talking about a square, so we know that the sides are 90 degrees. And here we are just in the middle of it. So this is 45 degrees. So here also we have 45 degrees. All right, so then we go. What is the force from 4Q in the x direction? Well, K, 4Q, 2Q where we are, divided by L squared. But now we have to be careful. We are looking just at the component in the x direction, so cosine of 45 degrees. In the y direction, very similar, but no, so K, 4Q, 2Q, and then the sine of 45 degrees, all that divided by L squared. That's it. So now what we need to do is to add all of these forces in the x direction, all of the forces in the y direction, and we'll get the components of our net force. With them, we use Pythagoras to get the magnitude of our force. All right? And how are we going to get the angle? Well, we can use the ratio between Fy and Fx. And we'll have to be careful to check in which quadrant we are. Okay, so this is the idea of the problem. Then part B is the same story again, but then we move to a different corner of the square.